Section 1, Chapter 3, Lesson 2. So we're doing factoring trinomials in the form of ax squared plus bx plus c, focusing on when a is not 1 today. And so we'll use a method called decomposition. So just a little warm-up just to kind of get used to the look. So just, FOIL these out. That's what they want you to do. So 2x times 3x, 6x squared. 2x times 4 is 8x. 1 times 3x is 3x. So we have 11x in the middle. 1 times 4 is 4. And so just understand that if these FOILed out gives me this, then the thing we just wrote, factored, is that. Just kind of knowing that's the other direction. Okay, that's all I'm helping you understand there. The second one here, same thing. I'll just FOIL. 3x and 4x, 12x squared. 3 times 3x for 9x. Negative 8x. So 9 minus 8 is x. Negative 2 times 3 is negative 6. So again, the idea that this factored goes back to that. We don't need algebra tiles much for our level. I'll briefly talk about them, but we'll mostly just do the factoring piece with them, okay? So don't focus on the algebra tiles like we haven't really done algebra tiles since Math 9, so. All this is saying, just write the expression for the group of algebra tiles shown. These are squares, so you have 2x squared. These are x's. So we have 1, 2, 3, 4, 5, 6, 7 x's. And then we have 6 units. 2x squared plus 7x plus 6. So to arrange the algebra tiles into a rectangle and state the length of width the rectangle is. And so I'll just kind of give you a brief what they're doing. They're putting the two squares together. So here's the two squares. And they're lining up 4 x's here below them. 3 x's here. And just to kind of help people with the pattern idea, which is, it's interesting, and there's the 6 ones. So they've done is they've taken this group of stuff, they've arranged it to a rectangle. Why a rectangle? Well, factors are essentially 2 binomials multiplied, right? So it's kind of like length times width you could think of in terms of this picture. Well, this picture, if you arrange your tiles of a polynomial into a perfect rectangle, that essentially is the factors. So what's weird about this is, what is this length? It's not x squared. The length, it's x. It's the length of x, right? So to figure it's x times x. So this whole thing's x squared, but this length is x. So how many x's do I have? 2x. And then what's this length? It's a 1. So this right here stands for 2x plus 3. Okay? You're not going to have to do this, just to help the visual with the pattern, okay? So if you're freaking out about this, just hold in. That one is x plus 2. These are the factors of that polynomial. Okay? 2x plus 3 and x plus 2. Okay? So we use the algebra diagram to just figure out what we just did. So essentially what we did is we just said that by the picture there, 2x squared plus 7x plus 6 equals 2x plus 3 and x plus 2. Okay. Let's have one more little piece here. Okay. So this is factor using the algebra tiles. So this one, we're going to go ahead and not do the algebra tile part. I'm going to go ahead and just kind of jump to where we're going to work at with decomposition. Okay. So here's kind of your first thing of decomposition. So what we use for decomposition is we want to break the middle up into 2 x's. That's why it's called decomposition. You're kind of undoing. And when you get a group of 4, what was our strategy for factoring groups of 4 yesterday? Or Friday. But yes, factoring by grouping. When you have groups of 4, we factor by grouping. Decomposition, you're going to factor by grouping every time. Okay? This is how you do it. First step, if you want to write steps down, we're going to go A times C. That means front times back. 5 times 2. 10. Okay? And then we're going to say, what are factors of 10 that add up to 7? 2 and 5, the ones we just did, right? So factors of AC that equal the middle. So it is 5 and 2. And this is the decomposition step. We'll say undo middle. So what we're going to do is we're going to write 7x as 5x squared plus 5x plus 2x plus 2. I wrote the 7x as 5x plus 2x. So I did not change it. We just wrote it differently. And now we have 4 terms. And we're going to factor by grouping. So that's your steps. Factor by grouping. Okay? So 5x squared and 5x, they both have 5x in common. That gives you x plus 1. 2x plus 2, they have a 2 in common. That gives you x plus 1. With those factors matching, that is a factor. So x plus 1 we can pull out now, right? X plus 1 is a common factor of these two groups. So we pull x plus 1 out, and what's pushed together? 5x, 5x, and 2. You just completed today's lesson. That's what we're doing. We're going to do a bunch of examples, though. Okay? 5x plus 2 times x plus 1. Order never matters on these. It doesn't matter the order of your binomials. Okay? Maybe I should have wrote the steps over here. Pretty good space I left over here. But anyway. Okay? Any questions on that? That's decomposition. That's what we're going to do this whole time. Okay? They're going to walk us through some things to look at now. Everybody good? Okay. So, factoring a squared plus bx plus c using the method of decomposition. In the warm-up, we multiplied that out, and we got what it was, what it looked like in terms of its binomial factors versus its trinomial. But how do we know how to split 11x into 8 and 3, and 2 and 9, and 5 and 6, etc.? So they're pretty much saying that when we multiplied this out here, this right here, we got 3x and 8x, right? So how do we get 3x and 8x? Well, what are factors of 6 times 4? It's 24. What are factors of 24 that add up to 11? 8 and 3. So that's how you know how to break that up. That's what we talked about. Okay? And so they're summarizing through that. They're summarizing the second one. I'm just going to get right to the examples, guys. Okay? So let's try this one. So step 1. A times C, 12. Factor of 12 will get you 7, 4, and 3. Rewrite with 4 terms. Now, another thing, I know you guys are writing, so I'll wait a second. It doesn't matter where you put them. Like 3x could be here, 4x can be here. It doesn't matter. It'll still work out. Okay, so it doesn't matter how you place your breakup. Okay? So now we're factoring by grouping. Step 3. Pull a 2x out on the first one. We get x plus 2. Pull a 3 out. X plus 2. And we're happy because x plus 2 match, so we are done. 2x plus 3, I'll write first this time, times x plus 2. That's it factored. B is the same one we just did. Yeah, we don't have to do that one again. That's the one that we jumped, so we can just say did an example 2, because we didn't do algebra tiles. Okay. All right, so I'll do A and B here, and I'll challenge you to try C on your own here. So let's do A and B together for example 4. All right, they were through a negative in now. So 6 times negative 3 is negative 18. So we're still looking for a factor of negative 18 that gets you 17. Well, it has to be 18 and negative 1. 18 minus 1 is 17. So we go 6x squared plus 18x minus x. You can put a 1 there if it helps you. Minus 3. Left side has a 6x in common. Right side has a negative 1 in common. We got our x plus 3 is the match, so we're happy. So we're going to go x plus 3 times 6x minus 1 gets pushed together. Okay, I'll do one more here where I'm probably going a little bit too fast, sorry. And I'll let you try part C. Kind of slow down and see if there's any questions before we move to the negative stuff there below in GCF. All right, 3 times negative 8, negative 24. Factors negative 24, that's negative 2, negative 6 and 4. So we have 3n squared minus 6n plus 4n minus 8. So now we're looking to GCF each. First one, 3n, n minus 2. Second one, 4, n minus 2. N minus 2's match, so we feel good about our factoring. 3n plus 4 times n minus 2. Okay, so I'll pause the video right now, let you guys try C. Just go until you get stuck or until you maybe help with the step. All right, so in this last one, let's see how you did here. So then 12 times 1, looking for 12. Factors of positively gets you negative 8, would be negative 6 and negative 2. Okay, so then you'd be at 12x squared minus 6x minus 2x plus 1. We pull a 6x out, 2x minus 1. We pull a negative 1 out, 2x minus 1. And that's where you are. 6x minus 1 times 2x minus 1. Okay. Got a few more here. Okay, so we got some that are written backwards here and then one that we can GCF first. So we haven't done it yet because we couldn't, but always still your first step is still to check for GCF. So in part B here on example 5, we can GCF. Part A, we can't because of 7. So this one, don't worry about the order here. Just go, what's 15 times negative 2? It's still negative 30. What are factors of negative 30 that get you 7? Negative 10 and 3. Good. So we still would keep the same stuff. And so now we're at 15 minus 10x plus 3x minus 2. Oh, sorry, it's a y. 10y, 3y, and 2y squared. And we're back to grouping. The thing that's nice about this is the orders only matter because we're still going to group it the same. 15 and 10, take a 5 out. That gives me 3 minus 2y. Here we're going to take out just a y. That gives us 3 minus 2y again. So we're happy they match. 5 plus y gets pushed together. 3 minus 2y is the common factor. Okay, as I indicated, we have to take a 5 out first here, just to make our lives a little easier because it makes things smaller. You don't have to, but if you do 15 times 10, you're looking at 150. So that's just not factors you're probably used to. But if you go 3 times negative 2, you got negative 6. Factors of 6 that give you 1, that's 3 and 2. So it's a little bit easier. 3 and negative 2, I mean. And people ask all the time, what happens to that 5? The 5 just hangs out. It just stays there. Okay, just put a bracket here. So it's going to be 3k squared plus 3k minus 2k minus 2. And then we're grouping these. $3k squared and 3k have a 3k in common. Gives you k plus 1. Have a negative 2 in common. K plus 1. And so we pull the k plus 1. So you have the 5 still sitting here that keeps coming down. We have the k plus 1 that we have right here. And then we push together the 3k minus 2. And now we have it all put in there. Going to do a little bit of double variable stuff, and then we're talking about some perfect square trinomial patterns, and then we'll be done. Okay, any questions? Okay. It's definitely a concept that just kind of rolls off for me a little bit quicker just because of the multiplication, like the patterns. So if you need something clarified, please ask. Don't let me just mow you over. Okay. So this one here, we don't care about the x squared and the y squared right now. Okay. So all we still care about is still doing 2 times 2, which is 4. Factors of 4, they get you -5, -1, -4. All that process is the same. Okay? Now where it gets a little different is we're going to break up -4, -1. What breaks up to that? These xy's do. So we're still going to write 2x squared. We're going to write -4xy. And we're going to write -xy. Again, the order of these doesn't matter. And we're going to write plus 2y squared. So nothing's really been different so far compared to the old stuff. You just have to pay attention to your common terms now. So what's that first bracket have in common? 2 and an x. Good. 2, and they both have an x. So that's what we're going to take out. So that gives me x minus 2y. So I took a 2x out of here, so the 2 and one of the x's came out, 1 left over. 4 divided by 2 for -2, the x came out, the y's left over. What's the right bracket have in common? -y. Good. Always take your first term's negative, just heads up. And so that gives you x minus 2y. So we're happy because they matched. And so see, it wasn't really that bad. So it's going to be 2x minus y times x minus 2y. That's your final answer there. Okay, this last one here before we go to the next page. So same thing, no GCF here, so we're just going to go 2 times 35 for -70. Okay, and then we're going to go -10 and 7. That's the breakup. So 2n squared minus 10nm plus 7nm minus 35m squared. Got a group, GCF, gets a little tiresome, doesn't it? Kind of the same thing over and over. It's definitely a repetition lesson. Okay, pull the 2n out. That gives you n minus 5m. Pull the 7m out. That gives you n minus 5m. So your final answer on this one, right there, 2n plus 7m, n minus 5m. Okay. All right, so the last thing we're talking about is perfect square trinomials. So these are trinomials that break down to perfect p plus q squared. So the same thing repeated. Okay, that's what they mean by perfect square trinomials. So, like for example, x plus 2 times x plus 2 is equal to x plus 2 squared, right? It's the same thing repeated. So that's what they're talking about, perfect square trinomials. So we're looking for these as just ideas of when something we're factoring is a perfect square trinomial. So if you did square this out, hopefully you understand the pattern of this would be p squared plus 2pq plus q squared. Why? Well, because you get 1pq plus another pq, which is the 2pq, p squared, q squared. So that's the pattern every time. So that's what's going here. And this one's the same exact thing except for a minus 2pq. Okay? That is the pattern of perfect square trinomials. The front and back are squared. The middle is 2 times the front and back multiplied. So from above, the first term of the trinomial is the square of the first term. So I said the first term is the square of the first term. The last term is the square of the last term. The middle term is twice the product of the first and last term. So the 2pq. So we can use this pattern to figure out if these guys down here are perfect square trinomials. So what you can do is what's the square root of a squared? A. What's the square root of 4? So we're thinking it could be this, right? How do we figure that out? Well, what's 2 times a? 2a times 2. 4. Boom. Yes. That's how you check for perfect square trinomials. This b is already a no way, right? Because of the y. The 6. It's not a perfect square. Can't do anything with that. So no. These bigger ones is where it helps see it a little bit better. So hopefully you guys can do it. Square root of 4x squared. Yep. Square root of 81. 9. Now, whoops, not plus. It's not plus because there's a minus right there. It's 2x minus 9. So we want to see if this is true. So we got 2x squared is 4x squared. Negative 9 squared is 81. 2 times 9 is 18. Times 2, 36. Yes. So you times p and q, times that by 2, and then you're in good shape. Last one looks maybe, because it's got 16. Ooh, problem. We can't square something and get a negative. They have to be positives. So can't because of negative. Negative c. We can't because of negative c. You'll never have a perfect square trinomial with a negative c. All right, so furthermore to that practice, we're going to fill in these blanks to make these perfect squares, right? So if we know the front's this, the back's this, we know it's x plus 10 in here, right? So then what's the middle? 20x. 10x times 2, 20x. Same thing for this one, right? It's just minus 20x. See if you can find part C here on your own. I'm giving you a lot of answers here. See if you can find part C on your own real quick. Yep. So you got 5x plus 6 is what we're looking at. 6 times 5 for 30. Double for 60. These are where they came from, so we know. All right, this last one only wants to do the end, so that's tricky. So 9m squared, right? We know 9m squared, that makes it 3m. So we don't know this guy right here. We know it's a plus, though, because it's plus plus. So how can I figure out that last one? Okay, how did you do that? 24 divided by 2. Okay. 12. So you found that 24 divided by 2 is 12. What number times 3m is 12? 4. So that's what's 4 squared? So 16 is the number that goes there. Okay, you're still working around your patterns to fill in that missing value. Okay? All right, last piece here, and I'll stop talking. Now we're straight up just going to factor these guys. Finish with the fraction one. All right, so this one, 49x squared minus 14x plus 1. So what I suggest is when I notice perfect squares front and back, I'm just going to try that first before I go through the factoring process. So I'm going to see is 7x minus 1 the answer. 7x squared is 49x squared, negative 1 squared is 1. 7 times negative 1 is negative 7, times 2 is negative 14. That's good. Third one backwards. If you don't like this written backwards, just flip it. Put the 25x squared in front. You'll still be fine. I'll just stay in their order. It's fine. So is it 4 plus 5x squared? So let's see. 4 squared is 16. 5x squared is 25x squared. 4 times 5 for 20, doubled to 40. Now, this is where I tend to get people. is 1/9 a perfect square? It is. It is. A perfect square is anything that comes out clean. If I square root 1/9, remember that's square root of 1 over square root of 9. So it's 1/3. Okay, so 1/9 is a perfect square. It's 1/3. So that means we're going to go 1/3 a square root of 9b. So that's going to be, there's a negative, so minus 3b. So we're looking to see if that's the answer. Okay, so if we go 1/3 a squared, 1/3 squared is 1/9, a squared is a squared, 3 squared is 9, b squared, okay? 1/3 times 3 is just 1, so it's just ab, times 2, 2ab, yep. So that's it. Okay? Okay, definitely strongly encourage you. This is, like I said, it's a repetition section. Your workbook's going to be important for decomp, especially if you're feeling overwhelmed with factoring. The more practice on these, the better with your routine, okay?